Welcome, Calculus BC. This is lesson 3.5, approximating with a tangent line. Let's go. So, in some cases, you have to find a value of a function that's difficult or impossible. And so maybe you have some weird function. So what we can do if it's really weird, we can actually approximate that function using the y value of a tangent line. So sometimes we call this the local linearization approximation. So instead of actually plugging in like the x value to the function, we just have a tangent line like really close to that point, and we plug it into the tangent line. We say, close enough. So what does that look like? Here's an example. Say I have this function right here of a circle, and I have a tangent line at this point to -2. I'm going to use, and this I can use this to write an equation of a tangent line. We could do this right now if we wanted to. I don't. But maybe I want to use this tangent line to approximate the coordinate, x coordinate at 2.1. So maybe 2.1 is like right up here. And I know it's not the best example here, but you know, it's close enough that we say, let's just use the equation of a tangent line instead of plugging into the original equation to figure out what y is. So we can use the tangent line, we say, close enough. So let's actually do this. So, I guess I do need to figure out the equation of the tangent line. All right, so we got to use our old friend implicit differentiation, because we got to find, so we have a point, we got to find the slope. So we have x squared, so derivative of this is going to be 2x plus 2y times y prime, because I'm lazy, plus 2 times y prime, easier to write, equals 0. And now I'm going to plug in 2 for x and -2 for y. So we get 2 times 2 is 4, plus 2 times -2 is -4 y prime, plus 2 times y prime equals 0. Combining like terms, those two is -2 y prime. And I'm going to move this guy to the other side, so it'll be equals -4 when I subtract. So y prime equals -4 over 2, -2, which is +2. Okay, so my slope, y prime, is that. And I can write my equation as y minus -2, so y plus 2, equals 2 times x minus 2. There's my equation of the tangent line. And you know what? Let's actually put it in y equals form. So I'm going to distribute this. So y plus 2 equals 2x minus 4. Subtract 2, y equals 2x minus 6. So that's the equation of this line, A. Now I'm going to plug in 2.1 to x. So I get y equals 2 times 2.1, 1 minus 6, which is 4.2 minus 6, which is -1.8. So the approximation for y is -1.8 at 2.1. All right, and I could do the same thing for 1.9, but you don't need to see that. No, I can do that. Y equals 2 times 1.9 minus 6 and blah, 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 3.8 minus 6. So -2.2. Okay, so we can use this to approximate that. That's all you do. And so we can do this other weird thing. So this is a different way to look at this problem. F of 2 equals 3, and f prime of 2 is -2. That means my slope is -2. Use local linearization to approximate this guy. F of 2.1, you're like, well, where's the function? Okay, well, you don't need the whole function. If we know we're going to have the equation of this line right here, and this means I have a point on the equation. 2, 3 is a point. Aha. And I have my slope. Aha. So I can write y minus 3 equals -2 times x minus 2. I can distribute that, so it's -2 plus 4, add 7, so I get y equals -2x plus 4, -2x plus 7, because you add 3 to that. All right, so there's my equation of the tangent line. I don't even need that function. I can just use it to approximate. Y equals -2 times 2.01 plus 7. So I get -4.02 plus 7, which is going to be 2.98. So there you go. I didn't need the function, but I used the same process as before. Now you're going to ask me, what's the point of all this? Why didn't I just plug into the function, right? Right, yeah. So some functions are hard to evaluate. And like e to the x, okay? If I asked you to find e to the 1, it's just e, right? Which is like 2.728 something. We know what this is. But if I asked you to plug in 1.01, Like, what's that? You can't do that in your head because that makes it hard. But you're like, wait, I just have a calculator, right? So it's not hard, it's hard. But this is kind of a simple example. Think of it this way. What if it was like a really big function and it took computers a long time to do it, or a calculator a long time, and then you're like, I don't care to just chug the numbers that long. I just want to get an approximation. So you just make the line, it's easier. Right?